Carefully understand what I'm going to do with this example. Let's say I'm writing a class called sample with some private field, integer and value. And now I'll be writing a setter and getter. And don't need to write, I can generate it, select the value and generate the setter and getter. It's fine. Now, how to use that class? You create an object for sample and then you can set the value, set value of 10 and you can say or instead of this, let's say obj dot get value. Now this is good. Now when you print it, you will also see the value. That is fine. Now this class is applicable only for integer. What if I want to set it to double? Let's say I want to use it for double. Now this doesn't permit because the set value requires an object of type integer and hence it is not applicable for double. Now if I change this class for double, what if I want to use it for float? It is not going to work. So to make it applicable for all types of values, I might have to make it object. If I say object, so now it works. The only adjustment that you need to make is you need to, because the return value for get value is of type object, so we need to typecast it to integer to make this assignment work. Now this is good. Now again you got it, and now what if I set this value to a double? It didn't complain. See, the value that you are passing here is an object of type double. Now what is expected is an object, what you are supplying is a double. Java does autoboxing for you. So when you say 10.2, it's going to create a double object with value 10.2 and then this object is passed as an argument. Now in that case, because you are passing double and what is expected is object, this works. But the other side of it, see, when you are trying to get the value, compiler did not complain because the return type is object and object could be an integer as well. But at runtime, this cast will throw an exception. Now when you see that, it resulted in class cast exception because the value java.lang.double cannot be cast to integer. So this is the kind of problem that we will face if we are actually writing the code for object. Instead of writing the code for object, what we can do is we can write the code for some template type. Let's say T. Now here the type for value is T and the return type is T. What is accepted is a value of type T. Now see how this code is transformed. Now when you want to use this sample for integer, you just say that I want to use T is of type integer. When you say T is of type integer, it won't accept the double value anymore because here in this within this instance, the T is of type integers, hence the code is written for integer. Now it is not going to accept this value of type double. That is fine. Now the same code, if I want to use it for double, I can still do that. I can say I'm going to create an object for double, which is object 1, and I'll say it is of type double. Now when I am trying to set the value, I can set a double value, and when I am expecting a value, I know that it is of type double. I don't need to even typecast it because this works for double, because the return type for get value is t itself. Now in this case you don't even need to typecast because the return type for get value is t, which is nothing but integer in this case. Now in this case the return type for get value is double, so hence you don't need to typecast. Now when I say t is string, this class is now transformed for a string. This way we can write a class which is generic enough to accept any value of type t. It may not be t, just as a literal we took it. We can use a different naming convention as well. You can say type and you can use type inside it.